I'm here with Ken Rovat, and he is a microgravity data analyst, and we're talking about one of the longest running payloads on the space station, SAMS. What is SAMS?
SAMS, that's an acronym. It stands for the Space Acceleration Measurement System.
So we're measuring the vibrations, I guess?
Yes, very minute, very tiny vibrations.
So I guess we don't think about the space station vibrating, but what kinds of things make it vibrate, and why do you have to measure this?
Okay, so on the very low frequency end, below about 5 hertz or so, we're actually monitoring the structural vibrations of the space station. There's very large structures, a truss, sort of the skeleton, the backbone of the space station, and that thing is actually oscillating at about 0.1 hertz all the time, continuously. And when the crew moves around, they have to push off or land on structure. They actually excite those structures, and so those vibrations are important to the longevity of the space station. A structure that's constantly bending and flexing, it only has so many of those load cycles before you have to say no more. So that's on the low frequency end. On the high frequency end, we're looking at very tiny vibrations from experiment equipment like fans, compressors, any sort of rotating machinery will vibrate. And also life support equipment also vibrates.
So it's not really of any interest really to the crew about vibrating, but it is very interesting to, I guess, the principal investigators and their payloads.
Yes, so our two primary customers are principal investigators trying to conduct science, and they're in the microgravity environment for a reason. They want to take advantage of a pure, pristine environment. So we're sort of the environmental monitoring for microgravity. We'll mount a sensor right near their payload, and as they conduct their science, they will often try to correlate or sometimes correlate what's happening in a vibrational sense to what it is they're actually studying. So we can provide them that feedback, and they can use that to make more sense of what they're seeing in their data. And then another big customer of ours is at the Johnson Space Center. There's a loads and dynamics group. They're in charge of validating a model of the space station. So if you imagine on Earth, bridges and so forth, you can have engineers go out and sort of take a look at that bridge for structural health and life, whereas SAMS provides 24/7 coverage of space station vibrations. So we help with that model validation, and that ultimately plays a role in extending the life of space station or giving feedback to the program about where we're at in terms of these loads and dynamics and how far out in the future we can go.
And we're here in the Telescience Support Center here at Glenn Research Center. This is, I guess, data ground zero, where it all comes to, right?
Yes, that's true, for SAMS and MAMS and various payloads for the space station. And so the consoles that you see here are where we receive this SAMS data from space station.
Can we see some of that data up close?
Sure.
So Ken, is there a whole lot of shaking going on when they're exercising?
Absolutely, Lori. So in this particular case, we're looking at velo exercise. And if you look at this somewhat schematic down here in the lower right, the SAMS sensor that we're going to talk about here in a second is located in the US lab, and about 100 feet away in the Russian service module is where the actual exercise is happening. So you can see that events in one part of the station have an impact on another part.
But you have sensors strategically placed throughout. Where are the sensors?
Yes, we have 8 sensors on space station right now for SAMS. They're located in all 3 labs, in the US lab, in the Japanese lab, and in the European lab. These sensors are designed to pick up very minute vibrations over a wide frequency range. So they really do a great job of monitoring the microgravity environment and giving feedback to investigators who need to know this information.
Can you show us one of the sensors?
Sure. Yep, right here we have one of the SAMS sensors. This is just a mass model that we keep on the ground, but it's representative of what you'd see on orbit. And so you see that the sensor has these what look like knobs on the 3 ends. That's because it's a triaxial sensor head. So it's measuring accelerations in this direction, what we call the x-axis, in this direction for this sensor, what we call the y-axis, and in this direction for what we call the z-axis. So all at the same time, we're getting 3 sets of measurements, x, y, and z.
And these measurements will continue as long as the station's there, right?
Yes, and not only will they continue as long as the space station's there, but they are helping to prolong the life of space station.
Fantastic.
Yes.
Thank you, Ken.
Thank you.